Okay, so let's start. Understand one thing. What you do nowadays, you try to create a project just by googling few points, like you want to make a project on face detection, or you want to make a project on some uh, let's say Twitter sentiment analysis, or you want to make project on credit card fraud detection, and so on and so forth. For that, you write your query on Google and you get some results. Using those results, you go on some website and you try to see some tutorial. Based on those tutorial, you write the same exact code, whatever they have written, without understanding the algorithm behind them. Why they have used that algorithm? What is the type of conversion, pre-processing, or text to vectors conversion? What all algorithms they are using? You don't understand them, and you simply copy that code, or you just try to understand the code line by line. I'm not saying you just copy that. I can say that you just try to understand that code line by line, and you don't understand the working behind those algorithms. This approach works well last 2 3 years ago, but nowadays in interviews what happens is, when you go some into some interview, they ask you what type of algorithm you have used, why you have used this algorithm, why not any other algorithm, or they want to understand whether you have some basic knowledge about those algorithm, what is the mathematical model behind it, if not whole mathematical model, but some glimpse of it, or you understand what are the different types of metrics you have used to analyze what are the results you are getting, whether the results you are getting is good or bad. They try to understand all those things. But if you do not but if you do not understand all such things, then the problem occurs, because in interviews you will not have those kinds of answers. So these classes, what we are organizing in an online mode, is to make you understand and you, so that you can answer those things into the interviews. So what are the different types of project we can make? So we can make the project using NLP, where our data set is in the form of text, or we have some data in form of images, data set in form of images. So for that we need image processing, or we have data set in form of videos, then what we do is video processing, and sometimes we have data in directly in form of numbers, or combination of both in form of numbers. So in case of numbers, we don't have to we don't need to convert our data numbers to any other form. We may need to rescale them, or we may need to convert our numbers into some different kind of vectors or matrices or something, but not as these kinds of data needed. Because what happens is, our computer or our machine understand 0 or 1. It does not understand the images, it does not understand the videos or the text or the speech. It does not understand all such kind of data. What it understands is zeros or ones. Converting our numbers into form of zeros and ones is easy. How we can convert any binary number into decimal, or decimal to binary? So this is binary representation of some decimal numbers. If we have decimal numbers, we can directly convert into binaries, and we can do mathematical operations such as addition, subtraction, multiplication, division on numbers. If we have vectors or matrices, we can do all such mathematical operations. But problem arises when we have data in form of text, in form of videos, or in form of images, or maybe speech. When we are speaking something that is neither text nor images or videos, we have plain audio only. So problem arises then, because we cannot do any mathematical operations on such kind of data. So if we have numbers directly, then we can apply machine learning models just by doing some pre-processing, very minimalistic pre-processing. But what we have is, let's say, text data. Then we cannot do direct machine learning model. We cannot apply direct machine learning models. What we have to do is we have to first convert our text data into numbers, and then we can apply machine learning models. So NLP is not directly applying machine learning models. Image processing is not directly applying machine learning models, or video processing or speech data. We cannot do machine learning, we cannot apply machine learning models directly. First, we need to do our data set conversion into numbers so that we can apply mathematical models. I believe this point is clear to everyone. And what are the necessary needs of such kind of data? Why can't we have numbers only? Because let's say we want to do sentiment analysis. And for sentiment analysis, we don't have numbers directly. We have some kind of blogs, some kind of comments or tweets, or some kind of other data in form of text, where we want to understand the sentiment of a person or a large number of person or a group. Or we have some kind of images where we want to detect something. For example, on the traffic, on the roads in traffic, we want to detect the car numbers who are violating the traffic rules. So we have images and we want to detect the car number which is not clear, and we want to find whether this car number is this or that. Similarly, inside a video which is of, let's say, CCTV recording of, let's say, 10 hours, and we want to understand within these 10 hours when that particular incident has happened. So one way is to watch that 10 hours continuously. Another way is to find using our models of first video to numbers, and then numbers on numbers we will apply machine learning models. So that will be easier way. No human intervention is required, only plain algorithms will run, and we will it will give us some period. Maybe it will say within this 5 minute activity is detected. Maybe it will tell us this, and we will go and watch that 5 minute videos to understand what has happened. So it is the case of, let's say, 10 hours. But what if we want to watch the CCTV of multiple cameras of 10 hours each? Then the problem becomes is more complex. So these type of things need our machine learning models, and before applying machine learning models we have to convert our data into numbers. For such all kinds of problem statements we need to learn the algorithms. So first what we will do is, first we will start with NLP and understand that how does NLP works, and then how we will apply machine learning models on that particular NLP data. So what I want to tell you is, one set of this problem is pre-processing, and another set is applying machine learning models. Okay, so this pre-processing is for NLP different, for images it is different, for videos it is different, for speech it is different. This pre-processing is different according to our data set. Whereas machine learning models is same, because once the data is converted into our desired format, then we can apply either RNN or LSTM or CNN or ANN or different kinds of machine learning models or deep learning models. So whether your data is having text or images or videos or speech, you can still apply all these machine learning models. But before that, you have to do pre-processing of your data. Until unless your data is pre-processed, you cannot apply any of the machine learning or deep learning models, because their input format is numbers. They do not accept data in text format or video format or images format. So let's start with NLP and subsequently we will go to other sections also, and we will understand how to convert our text data into vectors first using NLP algorithms, and then we will apply machine learning models on them. So first what we have is using NLP. For NLP we have data in text format. For example, we have data, let's say our data is sentence 1, sentence 2, sentence 3, and first sentence says that he is a good boy. The second sentence says she is a good girl. Third sentence says that boy and girl are good. So we have three sentences. You can understand we can have n number of sentences and each sentence can have n number of words. This is our data set in form of text. Clearly, we cannot apply any kind of machine learning model to these sentences directly, since we cannot do any mathematical operations on them. So first we have to convert these sentences or this data set into vectors. For that we have some algorithms. So the type of algorithms which we are learning today is first bag of words, and this is of two types. One is binary bag of words and another one is counting bag of words. The second type of algorithm is TF-IDF, where TF stands for term frequency and IDF stands for inverse document frequency. For each of them we have some formulas and then we make the metrics that we will understand by taking an example. And the third type of algorithm is word to vec. This word to vec algorithm is itself a type of a model which train on some data and gives us some result. And each of these algorithms have some limitations, some disadvantages and some advantages. So in nutshell, bag of words is very easy to apply. This is less computation demanding, but the disadvantage is it does not give any significance to semantics meanings. If meaning is lost. Whereas TF-IDF is very little computational demanding, more than bag of words, but it is also lost the semantics, but it gives some semantics more than bag of words, but not as much as we want. In word to vec, semantics are not lost, but it is very computational demanding. So it takes a lot of time to get us some results. So each have some advantages, each one of them have some disadvantages. Let's understand them one by one. First, what we understand is we have some data. He is a good boy, she is a good girl, boy and girl are good. Out of these sentences, some of words are not even related. Not related means they are not contributing to our gist of the data set. So here, if I write he, good boy, or even I don't write he, I write good boy, good girl, boy, girl, good, then also I will understand the same meaning. Because grammar is used for human. Grammar is not required for computers, for machine learning models. Why? Because it is not working on some particular person. It is working in generalization form. And when we are training our model, it is obviously that data is of the past. It is not of the future, because future data will not be get trained. Future data is not available with us right now. So data is obviously which is already present with us, which is of past. So now what we need to do is, first of all, we want to do some pre-processing before applying these algorithms. What kind of pre-processing? Maybe our data is having some unwanted characters. What are unwanted characters? Let's say question mark, exclamatory sign, at the rate, or maybe some junk characters, more number of spaces. So by using regular expressions, we can remove all such kinds of characters. For example, here we have full stop. I don't need full stop for doing natural language processing. I want to understand only the meaning of the whole document, not of single sentence. So I can remove this manually if I have only one full stop. But what if we have thousands or lakhs of sentences? So we will use regular expression for that purpose. And we will only use the English characters. Then it is having small characters and capital characters both. So for computer, girl starting with capital character and girl starting with small character is different. I need to understand that for me both are same. For computer it will treat it as different word. For treating it as same word, I need to convert either all the characters into capital letters or all the characters into small letters, so that girl and capital letter girl both remain same. So what I will do is I will convert all the capital characters into small characters, so that small case, or so that capital D Delhi and small d Delhi both should be treated as same. So first what I have done is I have removed all the junk characters or unwanted characters. Then I have converted all my characters into small case. Now I need to find the lemmatization. I need to do lemmatization or stemming. I will talk about lemmatization and stemming more after explaining these algorithms. So what is lemmatization and stemming? Don't worry about it. I will explain each one of them in detail. First, understand what bag of words do after removing all the stop words. So what I have done till now is removal of junk characters or unwanted characters, then converting all the letters into small case. So small case conversion. Then I will do lemmatization or stemming, that I am not telling you right now, but obviously we will understand that. So before doing this, let's say stop words removal. So what is stop words removal? There are some words which are not contributing much to our sentences, which I told you: he, is a, she, and, are. These are different types of words which are not contributing to the meaning. They are only contributing to the grammatical mistakes or errors. So good boy, good girl, boy, girl, good. Can also give us the same meaning. So there is a library which we have, or you can understand like this: we have a list of words which are considered to be stop words, which do not contribute much to the meaning. I will check each one of these words and match with that particular dictionary. If that word is available in that dictionary, I will remove it. If it is not present in that dictionary, that means it is not a stop word. For example, I have is here, a here, she here. So is he available in this dictionary? No. So I will take it. Is available in this dictionary? Yes. I will remove it. So this is stop words removal. I will match each and every word to our dictionary. If it is available, remove it. If it is not available, then it is not a stop word. I have to keep it. So we have a library in Python, stop words. Using that, we can remove the stop words. And after that, ultimately we will do either stemming or lemmatization, which I will explain you at the end. After doing all these tasks, then we will do conversion of text into vectors. Text into vectors using either of these algorithms: bag of words, TF-IDF, or word to vec. We will not use all of these algorithms. We will use either of them, because the work of each of the algorithm is same. Although there are some advantages and disadvantages, but purpose is same. Okay, so for your understanding, we have multiple sorting algorithms, like we have bubble sort, selection sort, quick sort, merge sort, and we have a list of integers. So to sort the list of integers, we will use either of the algorithm. We will not use all of them, because end result will be same, that is sorted list of integers. The process is different for each of the algorithm. Time complexity is different for each of the algorithm. and in some cases time complexity is so high that some algorithm will not produce the result, other algorithm will produce. For example, in some cases selection sort will not produce the result as it is having n square, and quick sort can produce the result because it is having less than n square in average case. Similarly here, so let's understand bag of words first. So what we have is, let's say I have removed some words from it. He is a, she is a, and are. So we are left with good boy, good girl, boy, girl, good. After all these four operations, we are left with these particular sentences only. So let me write here them again. S1 says that good boy, S2 says that good girl, and S3 says that boy, girl, good. Each of the word is in lowercase. We don't have uppercase now. Now we want to apply the bag of words. So for applying bag of words, first of all, what we have to do is find the frequency of each word. We will find the frequency of each word. So let's write word here and here frequency. Let's make a table of it. So we have a word good, we have a word boy, we have girl. How many times good is coming? 3 times. Boy is coming 2 times. Girl is coming 2 times. In the whole document, boy, good, 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 3 times. Boy, boy, 2 times. Girl, girl, 2 times. So we have written the frequency. Now, this is the frequency. Although it is required to find out the total number of words. Let's say what is the total number of words here? So we have total number of words as 7. And now we will convert it into vectors. Vectors. So what is the size of the vector? What is the size of the vector? So here the size of the vector is the number of character. So what is the dimension of the vector? Number of words on one side and number of sentences on other side. So let me reverse it. Number of sentences multiply or cross number of words. This is the dimension. So here number of sentences is 3 and number of words is also 3. So the matrix what we will make is 3 by 3. So let me make a matrix of 3 by 3 here. This. So here sentence 1, sentence 2, sentence 3. Here good, boy and girl. So here it is of 3 cross 3 matrix. When you will give this data to your machine learning model, you do not give this part and this part. You only give this particular part to as an input. Okay, so girl की frequency 3 नहीं है बेटे, ये girl की frequency 2 ही है. Now see this. In sentence 1, is good available? Yes. First let's talk about the binary bag of words in which 0 represent absent and 1 represent present. Okay, so now in sentence 1 good is present. Sentence 1 good is present, boy is present and girl is absent. So what I will do is I will write 1 1 0 here. 1 1 0. Then in sentence 2, good is present, girl is present and boy is not present. So it will do 1 0 1. In sentence 3, all 3 are present. So we will write 1 1 and 1. So bag of words is plain just binary representation of word whether it is present or not present in form of the each sentence. Nothing else. If we have to write the counting bag of words, so right now the result will be same because one word is not repeating in one sentence. Let's say this sentence was good, good, boy. In case of binary bag of words, this remains same. One is present, boy is present, girl is absent. But in case of counting bag of words, it will become 2. It will tell us the frequency of each word. So this will give you the frequency. In counting bag of words, we write the frequency. In binary bag of words, we only write present or absent. That's all. This is how we can find the matrix, this matrix, using bag of words. And this bag of words matrix can be given as an input to our machine learning model, and then we can do our predictions. Very simple algorithm. That's why I told you the problem with this algorithm is it lost the semantics. Here we don't know whether this girl, good, boy are related in some way. We don't know in which sentence they are related, although we can find by using this, but the semantic is lost because their occurrence of each word is lost. Whether good is coming before boy or boy is coming before girl, or I don't know any format of the word, which word is coming first in which sentence. We only know the present and absence. So the semantic of words, semantic of sentence is lost in bag of words. But it is very easy to make the matrix out of it. Very easy to make the vector of it. So very less computing power is needed. So this is plain bag of words. Now let's try to implement this bag of words using our Python. I have written code here. You just try to understand that. Or before that, let's try to understand lemmatization and stemming. Then we will go on to the code and understand how does it is working. So how does lemmatization and stemming is working? Stemming and lemmatization. Understand that in a word, in a sentence, let's say we have a word studying, or we have word let's say traveling, or we have some word which is not the root of the word, it is in some other form. For computers, whether it is in first form, second form, or in any other form, we only need the meaning. We don't want to know what is that form. For spoken English, we need those kind of things, but for understanding or making our model understand the meaning, we don't need those kinds of uh, forms. So stemming is a process in which we try to find the root of the word. Find the root of the word. Stem. So stem means in a tree we have a stem which is the main part of a tree. Without a stem, a tree cannot live. So in studying, the root of the word is study, or traveling, root of the word is travel, without which any other thing available in the word is not or is meaningless. It is slower, it is slower, but more accurate. Why it is slower? Understand that why it is slower. Because let's say we have a dictionary. I am just trying to tell you how the stemming is implemented inside the Python. I'm just trying to tell you, or trying to give you some glimpse of how to explain how the stemming can be implemented. Not exactly, but trying to make you understand. So let's say we have a dictionary, and this dictionary is having some words. Let's say travel is a word, then we have a word study, then we have a word let's say student, then there is a word, let's say city, there is a word, another word, let's say country. Obviously a dictionary will have more than 5 words. Here we are just taking an example. Now what stemming will do, this word studying will be compared with each of the words available in our dictionary, each of the words available in the dictionary. Why it is slower? Because it is very computational demanding. It needs lot of computation. This studying word will be compared with each of these words, and it will find the score with which word it is most matched. So if you match studying with travel, probably you will get 0 score. If you match it with study, probably you will get score 0.9 out of 1, if we are giving a score, then probably it will give 0.9. If you match study with student, it will give you maybe 0.88. With city, it will give you let's say 0.01. With country, maybe 0.02. So now out of all these scores, this is the highest score, 0.9. And this 0.9 score is given by study. So it will replace studying with study. So this is how stemming or root word is found using stemming. It is slower because if in our dictionary we have 1 lakh words, so each of the word will be matched with 1 lakh words and then it will find the score. Obviously, we can make some efficient approaches out of it. What we can do is we can select the first word S, first letter S, and we will match with only the letters starting with S. We do not match with travel, we do not match with city, we do not match with country because they are not starting with S. So there are very less chances study will match with these words. Obviously, out of 1 lakh words, probably 99,000 words will be removed. So we can make some efficient approaches out of it, but then also it is slower because we have to match each and every one word of our document with some words and find the score and then get the maximum score word and replace with it. It is more accurate because we will get the exact word which is the stem of that particular word, root of that particular word. More accurate. Whereas lemmatization is also used for same purpose, but it does not find the root of the word. It finds near root of the word. Not exactly the root of the word, but near to the root of the word. It is faster. Obviously, it is faster than stemming, but it is less accurate. You have to compromise with the accuracy if you want to make your process faster. If you want to make your process more accurate, then probably it will take more time. That is very first rule of doing anything. So in lemmatization, what it do is it make a prefix tree of all these dictionary words. We have a prefix tree of all these dictionary words and it matches. So understand how to make a prefix tree. That is another video. We will understand this some other day. Let's try to understand here. So let's say there is a tree S T U D, and from here we have one approach by Y, one approach with E, then ST, or let's say U N T, then there can be one S A N D, there can be S A T. What we have is this kind of a tree, and here what we do is we will follow our word studying, and we follow STUD, and after that we have Y. We have Y here. We go into this direction instead of going into this direction or this direction or this direction. But then it is not guaranteeing that we will get the same word, because there may be some other word which is having I also, which matches with our YI, but not actually study and making some other word. So here the chances of getting study as the word is less, whereas let's assume that there is some word in our dictionary which is having I and A also. So here what is happening, this is matching with this. Our studying is matching with this most, although this word is different, but it is matching with this. So it will give us this particular word instead of study. So since it is taking less space for making all the words one by one, is taking more space, and in this particular tree you can see that it is taking less space because one letter can be reused. This S is reused for each of these words. Each of these words S is written only once, and it is less computational expensive. Why? Because it is giving us login time. We are every time we are removing half of the tree, so it is faster but less accurate, so it is giving us near to the root word. So these two types of stemming and lemmatization, either or. So either we will use stemming or we will use lemmatization, we do not use both. I have tried to make few projects and understood that if stemming is giving 92% accuracy, lemmatization is giving 91 or 90% of accuracy. So the accuracy difference is 1 or 2% in most of the cases. And time difference is, if it is taking 2 minutes for some particular content, it is taking 1 minute. So time is almost half in most of the cases, uh, limiting to some special cases. So I try to use lemmatization for first actually trying to understand what my project is doing, or actually trying to see the results, first hand results first, and then make the optimization after it. So this stemming can be used once you are done with all the other things in your code, because it is taking a lot of time. At the time of testing, you want to run your code again and again, so it will take 2 minutes every time. Whereas when you are doing testing, you want to use less computational expensive things. So we will understand stemming and lemmatization both one by one. For stemming, we have a library in Python which is Porter Stemmer, and in for lemmatization we have a library word net lematizer. So these two libraries are used in Python for both the purposes. Now let's try to go to the code and understand how the code is working for each of them.